We're going to move on and look at the second assumption, and the second assumption is heritability, that the parents are able to pass on a particular trait to their offspring. In this case, we're going to look at a setup where we've got two different subpopulations of the sticklebacks, and we're going to see what happens to them before we look at what happens to our entire population. So we've got one group here that are low plate count. You can see that the mean plate count for our two parents is 10, so they only have 10 bony plates on average, whereas we have a high plate count group where our parents on average have a plate count of 26. So what we're going to do is we're going to have them reproduce, leave behind some offspring, and see what their plate counts are. We can record our starting plate count numbers up here just so that we can see what's going to happen as we run it. So we let it go and we produce offspring, and our low plate count stayed at 10. Our high plate count dropped to 19. We run it again. 10 and 22, 9 and 30, 10 and 32, 9 and 33. You can see that we're getting change each time, but in each case the low plate count group is staying low and the high plate count group is staying high. So we're seeing that the parents are passing on that trait to their offspring. Now we're going to remove heritability, so that no longer are we going to see the parents passing on the traits to their offspring. And we're going to throw a couple of fish in each of these. And you'll notice this time we're starting with roughly the same plate count in each. And we're going to see what happens as we run the simulation now. So we no longer have heritability, and what we would expect to see is that they both stay at about 25 or 26. You'll notice right away we've seen a change in the mean plate count in what started out as our high group. And each time we run it, we see that there is changes occurring. With occasionally the numbers changing pretty dramatically, so that we can't necessarily tell what's going to happen from one generation to the next. Sometimes it gets larger, sometimes it gets smaller, but we see that they're not staying nearly as close as they were when we were running it with heritability in place. What we can then do is look back at our full model, and we're going to run the full model again very quickly with heritability in place, just as a refresher for what happened. So we run it when it's murky. We end up with most of the individuals staying on the low end in terms of the number of bony plates. If we switch it to clear, so that now our cutthroat trout can eat our sticklebacks, we see a change as more and more bony plates are becoming the dominant trait. So that's what we see when we have heritability. Now, when we unclick the heritability, you can see that our average bony plate count sort of falls down into the middle. We lose those groupings. And that's because there's no longer any predictability, and we're just looking at most of them falling somewhere in the middle. If we run it now, when the conditions are murky, as we let this go, you'll notice it's not necessarily favoring individuals with fewer bony plates over those with larger or more bony plates. When we switch to the clear lake, again, we see no change overall. Pattern stays roughly the same. And it's because even if our individuals that have the bony plates are the ones that are surviving, they can't then pass on that trait to their offspring. So no heritability means no natural selection, means no overall change in our population.